before we dig into the example problems, any questions about the format of the exam? The only real difference from the midterm is that I'm giving you a much wider window in which to take the exam. Just there was a huge demand last time for different time slots, so I just opened it up a lot more. Other than that, should be about the same. So, any questions though?
When will it actually open up?
So it will be available Thursday this week, and I think yeah, I got it set to open up at noon, and then it'll be open all the way until May 4th before midnight.
Okay, perfect. Thank you.
Any other questions? All right, so with that sorted, and if you I'll have some time at the end if you have more questions. But with that sorted, let's go ahead and kind of dig into all these example problems. So I didn't clip the actual question here, but so this one is: consider this graph below representing a monopolistic market. What will price and quantity be, and what would the price and quantity be under perfect competition? So one of the kind of deals with this problem is that your curves aren't labeled, and so the idea is that you should be able to identify, knowing this is a monopolistic market, you should be able to identify which curve is which. So the upward sloping curve here is the marginal cost curve, which, as we know, is the same thing as the supply curve. But for a monopolist, the marginal revenue curve is not the same thing as the demand curve. The marginal revenue curve lies below the demand curve. So B is the demand curve and C is the marginal revenue curve. And the reason the marginal revenue curve lies below the demand curve is that for a monopolist, if they raise their price, or let me rephrase that, if they decide to cut quantity of output, they can potentially make more money because the price of the output that they are producing, even though they're producing less of it, will increase. And this is an option that a perfectly competitive producer doesn't have, right? Because if the perfectly competitive producer reduces their output, they're so small relative to the overall market that it's not going to move the needle on price. It's not going to cause price to increase. So that's why our marginal revenue curve lies below the demand curve. All right, so the rule for profit maximization is that marginal revenue is equal to marginal cost. So marginal revenue being the amount of revenue that each subsequent unit of output generates, and marginal cost being the cost of each additional unit of output. And so where marginal revenue is equal to marginal cost is right here. And this tells us the level of output, Q1. So I guess the cat is coming to join us. So for a monopolist, marginal revenue equals marginal cost, and that tells us quantity equals Q1. But when it comes to price, it's a little different because the monopolist isn't going to charge P2 because at this quantity, Q1, demanders are willing to pay all the way up here at the demand curve. So they're going to charge a higher price. So tracing that up and over, we get the monopolist price of P1. Now, to contrast this with perfect competition, with a perfectly competitive producer, marginal revenue would be equal to demand. So just like any other kind of perfectly competitive market, the perfectly competitive outcome would be where supply is equal to demand. And right off the bat, we can just read, okay, well, we're going to end up with Q0 and P1. Oh, crap, sorry. That was supposed to be P0 for the monopolist. My apologies, that's confusing. The higher price for the monopolist. And then for the perfectly competitive producer, we're going to be down here at P1. So if we kind of imagine that we're moving from the monopoly outcome to the perfectly competitive outcome, we end up with a lower price moving from P0 to P1 and a higher quantity moving from Q1 to Q0. So that's the idea on this problem.
I can do it for you.
So you might see this problem with numbers attached rather than, P0, P1, P2, but it's the same principle. Any questions on that?
Yeah, I have a question real quick.
Yeah, what's up?
So I guess I understand why we got what we got for the monopoly, but I'm still confused how we got what we got for the perfect competition.
Okay, so for a perfectly competitive, hey, hey, Sydney, could you mute your mic?
Oh, I'm so sorry.
All right, so for a perfectly competitive producer, the difference is that we've got a downward sloping demand curve, but that downward sloping demand curve is the same thing as the marginal revenue curve.
Mhm.
So there's no separate marginal revenue curve, and marginal cost is unchanged. And so just like we were finding equilibrium very early in the course, we kind of hit it at the beginning, but those were perfectly competitive markets. And so for the perfect competitor, you just go, the market outcome is just going to be where supply is equal to demand. And that's how we get P1 and Q0. Did that clear it up a bit?
I think so. Why wouldn't it be P2 and Q1?
So the reason it wouldn't be P2 and Q1 for the perfectly competitive producer is for the perfectly competitive producer, this marginal revenue curve doesn't exist. Because it's the same thing as the demand curve. They're one and the same just for the perfectly competitive producer.
Okay.
And the idea here is marginal revenue, think about it very concretely is kind of just price, right? Because for a perfectly competitive producer, they don't have any control over price, right?
Mhm.
And so their actual revenue, how much revenue they get per sell, is completely a function of how much they sell. And it has nothing to do with price fluctuations because they have no control over that. The monopolist, on the other hand, has some control over that, and that's reflected by the marginal revenue curve lying below the demand curve.
Okay, yeah.
Any other questions? Okay. So we can also present these kind of market analysis problems as a table. And this one just happens to be a labor market. So consider the table below representing a competitive labor market. What will the equilibrium employment and wage rate be? So here it's same old story as finding where supply is equal to demand in a product market. The only difference is your axes label changes. So your quantity becomes employment and your price becomes wage rate. And in a competitive labor market, we just have our normal supply and demand curve. So pretty straightforward to find the equilibrium outcome in this market. We find where labor supply and demand are equal to one another, and then we see the wage rate that corresponds to that. And we can see that labor supply and labor demand are equal to one another at 60. And the wage rate that corresponds to that will be $12. So fairly straightforward. Employment is equal to 60 and the wage rate is equal to 12. So we could have, say, a situation where labor supply increases, right? So let's say that we have an outward shift in the labor supply curve in this market. And let's just say that, actually, hold on just a second, I'm gonna use a different pen color. So say we've got an outward shift in the labor supply curve in this market. And let's say that at every single wage rate, people are willing to supply 20 extra units of labor. So with kind of our S prime here, we end up with 40, 60, 40, 60, 80, and 100. That might not.
It says
yeah.
40. It says 40 units on the review sheet.
Oh, it does. Okay.
Yeah.
Let's go with the review sheet and not go off script. So suppose 40 more units are supplied. Let me back that up. So 40 more units. So 20 plus 40 is equal to 60. 40 plus 40 is 80. There it is. Thanks for catching that. That saved me a lot of grief here in a moment. 60 plus 40 is 100, and 80 plus 40 is 120. And now we can see, all right, supply and demand are equal to each other at 80, and the wage rate has declined to 11. So employment has actually increased 80, but at a lower wage rate of 11. And that should correspond with our graphical analysis here. So let's do that real quick. So our initial outcome is the green lines, the subsequent outcome is the red lines. And we can see that wage rate declines and employment increases, just like we found whenever we were investigating the table. So any questions on that one? Feeling good? Cool. Yeah, these are very similar to a lot of problems we had in the first half of the course. All right. Let me get the next problem. So the next problem is from the inequality chapter. And one of the measures of inequality that we discussed was the Gini coefficient. And the idea behind the Gini coefficient is kind of imagine everyone in a country lined up from lowest income to highest income. And as you move across the spectrum of people, the height of the graph, or so the lowest income person kind of stands all the way over here, the highest income person stands over here. And as you move across the graph, you add up the income of every person that came before to the person you're looking at it. So this is a cumulative distribution of income in an economy. And so if an economy were perfectly equal, where everyone had the same amount of income, the Gini or the Lorenz curve from which we calculate the Gini coefficient would be this 45-degree line, because each person would contribute equally to this cumulative distribution. If we had a perfectly unequal society, then it would, where one person had all the income, then we would be sitting down here at the bottom of the graph until we get to the very last person, where it would suddenly spike up to 100%. So that's just kind of visually what's going on. To calculate the Gini coefficient, we compare the areas A and B. So we take A as a proportion of A plus B. So here I give you, if the area A is 1,000 and the area B is 3,000, what is the Gini coefficient? So we just need to plug it into this kind of simple ratio. So we have 1,000 over 3,000 plus 1,000, which is equal just 1,000 over 4,000, or 1/4, which is the same thing as 0.25. So let's imagine that instead we had a, let me make sure I'm not going off script again real quick before I start whipping stuff up. Okay, so let's imagine that we've got a different society where these ratios are different. So let's imagine that we have less area in B. So let's imagine that B is instead equal to 2,000, And A, let's say it's still 1,000. So if we calculate the Gini coefficient there, we end up with 1,000 over 3,000, which is just a third, or 0.33 repeating. So if we've got less area in B, then that means that we've got a more unequal society. And so when we have increasing inequality, the Gini coefficient also increases, as we saw here. Oh, sorry. Let me stare at this for a moment. Yeah. Yeah, that's right. I just wanted to double check that before I kind of committed it to this. So anyway, that's Gini coefficient, which is just one measure of inequality. Any questions on that?
Did you say that less area in B equals more unequal society?
Yep.
Okay, perfect.
Yeah, and oftentimes it is easier to kind of think about these border cases of like, what would a perfectly equal society look like in this? What would a perfectly unequal society look like in this? Despite the fact neither of those things ever existed. It's just a conceptual way to kind of figure out like which area corresponds to which thing. All right, any other questions? Okay, so we're going to have another labor question. Let me get that problem pulled up. Okay, so one stipulation here is on the exam, you won't be given this column. You'll have to calculate it, and we'll do that as we go. Additionally, you don't necessarily need the marginal factor cost of labor column if I tell you that the labor market is competitive and what the wage rate is. So before we dig into it, let's talk about what each of these things kind of mean conceptually. If you notice, our kind of first column here isn't quantity like it is in a lot of our tables. It's employment. So we can think of this as number of employees.
Bro.
Hello, what? Okay, so anyway, we can think about this as number of employees. And so we can see how the total revenue of the firm changes as we hire more employees. So all of this is happening because the firm hires workers, those workers produce some output, which the firm can then sell. And so the firm is trying to figure out what the optimum level of employment is, the optimal number of workers to hire. And to do that, they compare the cost of hiring a worker, the marginal factor cost of labor, to the revenue they get from hiring the worker, the marginal revenue product of labor. And so they're going to continue to hire workers until marginal revenue product of labor, marginal revenue product of labor is equal to the marginal factor cost of labor. And if we look at this graphically, we can put this in dollars, we can put this in employment, and we can see that the marginal factor cost of labor declines and the marginal revenue, oh, sorry, I did the wrong thing. The marginal revenue product of labor declines. And in this example, the marginal factor cost of labor remains constant at, in this case, 60. And so we're really just trying to find that point, this level of employment and this wage rate, basically, which we know what the wage rate is because it's going to be fixed. All right, so pretty straightforward here. We just find where the two values are equal to one another, 60 and 60. And that corresponds to a total revenue of the firm of 240 and an employment level of 3. So how many workers will the firm hire? 3. But let's talk about how to find the marginal revenue product of labor. If you're given the total revenue column with connected to the employment column, it's fairly straightforward. Just like finding any of the marginal values we found throughout the course, you get at it by subtracting subsequent values. So here it's 100 minus 0, which is clearly 100. And then the next one, it's 180 minus 100, which gives us 80, and so on. And so that's how you would get that column. Any questions on that one?
So, wait, sorry.
Maybe mute your mic and just type it in chat. We are having all the sound problems today. I'm going to go ahead and queue up the next question, but we'll come back to yours once you get the question typed up. Boop. All right. Yeah, so that's pretty much all you need to do. So like, so I don't know if you guys can see the chat, but she asked, so you said that you find the marginal revenue product of labor, we just need to subtract the number before. Yeah, so like, for instance, if we will find the marginal revenue product of labor of this third worker here, we take 240 and we subtract the total revenue value that came before it. So this one would be 240 minus 180, which leaves us with 60. And that's how you would fill in that column. And I'll just do the last one. So 280 minus 240 leaves us with 40. Something I didn't talk about that is just kind of an important conceptual point. The reason why marginal revenue product of labor declines as you add more workers is that the ratio of factors of production are changing, particularly the ratio of capital to labor. So if you add more and more workers, you're not getting more and more machinery, right? Because we're not adding those things in this example. Those things are decided in the long run. And maybe it's just my time I spent in the fast food industry as a younger person, but the example that always comes to my mind is, you know, working the grill at like a burger joint is like, you can add more and more cooks to the kitchen, but at a certain point there's really only one grill, and so adding additional cooks doesn't speed up production. It doesn't allow you to make more burgers more quickly without adding more capital. Anyway, so let's move on to this next question, number 5 here. So suppose that a firm has fixed costs of 1,000, variable costs of 2,000, and the firm is currently making $1,500 in revenue. Should this firm continue to operate in the short run? And should they continue to operate in the long run? So let's start with the long run because it's a bit easier. So in the long run, the decision here rule is very simple. If the firm is making a profit, you continue to operate. Pretty straightforward. So we can see that this firm has total costs are equal to variable costs plus fixed costs. So here we've got total cost of 1,000 plus 2,000. So we've got total cost 3,000. And so $3,000 of costs with $1,500 of revenue. The firm is making a $1,500 loss. So yeah, the firm should shut down in the long run. They should exit. In the short run, the decision becomes a little more difficult because in the long run, you just get out of the business. You sell all your machines, you stop hiring workers, you're out. So your costs go to zero if you exit. But some costs cannot be altered in the short run, and we call those fixed costs. So in the short run, you're stuck with your fixed costs, but you can get rid of your variable costs. The easiest way to think about this is like, imagine you're operating a warehouse. If you shut down, you still have to pay rent on the warehouse till the contract's out, but you can send all your workers home. So here, we've got fixed costs equal to 1,000 and variable costs equal to 2,000. And so the idea is if revenue is greater than variable costs, you should continue to operate. And the logic here is that if you can cover all of your variable costs, then you have at least something you can put towards your fixed costs that you're stuck paying regardless. But if you shut down, your revenue drops to zero and you're stuck with the fixed cost still. So let's think about the example of this firm specifically. Well, we can see that the revenue is 1,500 and the variable costs are 2,000. So we're in violation of our rule here. Revenue is less than variable costs. So this firm should shut down. Let's imagine a different firm. Let's imagine a different firm that is still making a loss, so they would exit in the long run, but they are covering their variable costs. So I'm going to change marker colors again. So let's imagine that we've got a firm with very similar characteristics. Let's say we've got fixed costs equal to 1,000, variable costs equal to 15, or let's keep that at 2,000. But let's imagine that we've got revenues equal to 2,500. And so just to illustrate this concept, because this firm, the revenue is greater than variable costs, so they should continue to operate. But let's demonstrate why that is by calculating this firm's profits, or in this case, losses, under each scenario. So we're still talking about just short run in both of these cases. So if they stay open and if they close. So if they stay open, they have to pay their fixed costs. Or so if they stay open, let's start with the revenue, 2,500. They still have to pay their fixed costs. And they still have to pay their variable costs because they're continuing to operate. They still got to pay all their workers. And we can see here that the firm ends up at negative 500, right? If they close, their revenue goes to zero. They still have to pay their fixed costs of 1,000, but they don't have to pay their variable costs because they sent all their workers home, zero. And we can see that once we sum all that up, we end up with negative 1,000. So for this firm, because their revenues are greater than variable costs, staying open and operating at a loss is actually loss minimizing. So that's why that's the case. So that's what determines the shutdown point for a firm in the short run. Importantly, even though this firm's making more revenue than the firm in the previous example, in the long run, they're still exiting. They're still exiting because they are making a loss. All right. Any questions on that one?
So basically, if you should leave long run if the revenue is less than the variable cost and the fixed cost, but with short run, um, you should stay open only if the revenue is greater than the variable cost.
100% correct.
Sweet, thank you.
All right. So the next question is unanswered in the study guide to provide an incentive for people to attend this meeting or to watch the video. So here we've got a graph of a market. Ooh, brush size just went. Okay, there it is. So here we've got a graph of a market with a negative externality. So remember that a negative externality is some cost that falls on someone not involved in the transaction, right? So, for instance, if a farmer sells wheat to, a commodities trader, right? And you happen to live downstream of that farmer, you might have to deal with the consequences of, nitrogen runoff from the farm. And so you didn't have any choice in that transaction. You aren't the commodities trader, you aren't the farmer, but you're still impacted because that transaction took place, because that farmer decided to operate and fertilize their fields. Maybe a little more concrete example is, many of us live in Salt Lake Valley, right? And if one person decides to consume a lot more fossil fuels in the valley, that increases the smog for everyone, regardless of their choice of, to consume fossil fuels or not. So anyway, it's just this third-party cost to a market transaction. And in this case, we're negative externality, so it's hurting someone. So to conceptualize this, we think about there being a private marginal cost and a social marginal cost. So the private marginal cost represents the cost structure of the firm producing the good. So because, because BP doesn't have to bear the costs of pollution, they artificially are kind of producing at a lower cost than is reflected in reality in terms of the sum total of costs experienced by society. And so because of that, the private marginal cost lies below the social marginal cost. So in the absence of any policy intervention of any kind, we're going to end up just where supply is equal to demand, or where private marginal cost is equal to demand. So in this case, that would leave us with a price of B and a quantity of E. Now, if we take into account all of the social marginal costs, the socially optimal outcome is where social marginal cost is equal to demand, where we have a price of A and a quantity of D. And so relative to the social optimum, the market delivers us a quantity that's too high at a price that's too low, a price that doesn't reflect the true costs of the production of that good. So there are many, but one policy proposal for dealing with negative externalities is to simply tax the production of goods that generate negative externalities. The clearest example of this that we've probably heard of is a carbon tax, right? Taxing the final sale of fossil fuels to reduce carbon emissions, right? So the name for this type of tax is called a Pigovian tax. It's a tax intended to align the market outcome to the social optimum by essentially artificially increasing private marginal costs so that they're closer to social marginal costs. So in this example here, I said if a Pigovian tax were implemented that perfectly accounted for all externalized costs, what would the outcome of the market be? And that would be the social optimum, where we have, a price of A and a quantity of D. So just some related conceptual points here. For one, imagine this example being, fossil fuels. There's still a lot of pollution happening under a Pigovian tax. It doesn't prevent the pollution from happening. It simply reduces it relative to what the market would generate on its own. Additionally, it's very difficult to calculate what the appropriate amount a Pigovian tax ought to be. That being said, it's pretty easy to say like, oh, there's a negative externality happening, so some Pigovian tax will get us closer to the social optimum, even though it may not actually get us directly on that point. And if we overshoot it a bit, we could still end up closer to the social optimum than we would in the absence of the tax. I believe in the lecture on that. Did I talk about the town of Pitcher, Oklahoma, and how it, like, even if there were a Pigovian tax, so I'll be brief. Pitcher, Oklahoma was a town that mined a lot of zinc and copper, and there's a lot of lead contamination as a result of the mining activities. And it was real bad time, became a Superfund site. The government bought everyone out and moved them away, and they're still dealing with water pollution afterwards. Big deal. But anyway, point is, if we imagine back, around the time of World War I, where this town started mining copper and zinc, that we had instituted a Pigovian tax at that point on copper and zinc to, put it more in line with the social optimum. That still doesn't prevent all of the lead toxicity that came afterward, because it would have still mined some, right? And so it's one thing to kind of think about is like, where does the revenue from a Pigovian tax go? Does the revenue from a Pigovian tax just simply go into the government coffers like any other tax revenue? Or is it being used to compensate the people who are actually hurt by the negative externality? So just something to think about. But anyway, any questions on this kind of idea? Okay. So the next one I got is about imperfect competition. So here we've got a oligopoly written out in strategic form. So we've got two firms, so it's a duopoly. Firm A can choose a high price or a low price, and firm B can also choose a high price or a low price. And we want to find out what the equilibrium outcome of this game is. Something I'm pretty sure I stressed in the lecture videos, but I also want to stress here is a strategic equilibrium is different from what market equilibrium as we've kind of come to think of it. Market equilibrium has certain ideas associated with it, such as like efficiency under conditions of competition, things like that. Strategic equilibrium has no efficiency implications, so different idea. But anyway, so the way that we find strategic equilibrium, also called Nash equilibrium, named after the guy who kind of originated game theory, is we use best response analysis. And so to succinctly state what that is, best response analysis is assume that each actor makes each individual choice, and then highlight which response would be the optimum response to that choice from their co-player. So let's start with firm A. And so here the payoffs are just numbers, but the first number corresponds to the payoff firm A gets in that outcome. The second number corresponds to the payoff that firm B gets in that outcome. And that's kind of convention within game theory. So let's assume that firm A chooses high price. what's the best response of firm B? Well, if firm B chooses high price as well, then they only get 1. But if they undercut and they choose to get a low price, they get 2. So firm B would prefer, if firm A chooses high price, firm B would prefer to choose low price. So we circle that outcome. I'm going to try to circle that in a way that doesn't cover it. Now let's do the next choice of firm A. So let's assume that firm A chooses low price. Then what is the optimal response of firm B? Well, firm B can choose a high price and get nothing, or they can choose a low price and get 1. So they'd prefer 1 to 0, so they'll pick 1. And so now that we've done that for firm A, we have to do the same thing for firm B. So let's assume that firm B chooses high price. What is the best response of firm A to firm B choosing high price? Well, firm A is, so firm A can receive 1 or 3. Well, they'd much prefer 3 to 1, so they'll select that. They'll select low price, they'll undercut firm B. And then finally, last one, let's assume firm B chooses low price. Well, then firm A's best response is either choosing high price or low price. Well, we see if they choose high price, they get 2, as compared to choosing 1 if they get low price. So they'll choose low price. And so any cell in this table that has both payoffs circled is a strategic equilibrium. And so the equilibrium outcome of this game is A chooses high price and B chooses low price. So we've got an asymmetrical game here where one firm chooses one strategy and the other chooses a different strategy. Oftentimes these games are going to be symmetric. One important note, which I do mention in the study guide, is that you should also be able to recognize when a game has no equilibrium or when it has multiple equilibrium, because there could be multiple equilibrium throughout the game. And in that case, the equilibrium is like the actual outcome that would occur is indeterminate. We don't know which equilibrium would prevail. Or a game could have no equilibrium, and therefore game theory can't really make a prediction. So, or at least this level of game theory can't make a prediction as to the outcome. All right. One other, maybe a little more subtle point on best response analysis is that if two payoffs are identical, you circle both. So if firm A's could choose high or low, and in either case they would get 4, then we circle both payoffs because the firm is indifferent between the two. That might also come up, so I wanted to at least mention it. Any questions on that?
I have 2 questions, if that's all right.
Yeah.
So just so I understand, so equilibrium is going to be where the outcomes are the same, but it's the highest one. So like it's not.
Nope.
Okay.
No. You have to go through the whole process of best response analysis each time. So the whole process of saying, assuming that firm A chooses high price, what's firm B's best response? Assuming firm A chooses low price, what's firm B's best response? And then do the same thing for firm B. You have to do that each and every time because it's not necessarily going to be the highest outcome.
Mm-hmm.
So, I mean, for instance, if I whip up, let's say, so this is firm A, this is firm B. So let's say we've got the same sort of game going on just for simplicity's sake. But let's change the payoff structure a bit. So let's say that at low, they get 1. At high, they get 5 and 5. But in these diagonal outcomes, let's say firm A chooses high and firm B chooses low. Let's say that they get that. Right. So the idea here is whenever one of these firms gets undercut, they lose all market share and their revenues go to 0. And we can do best response analysis here, and we'll end up in a different cell just because the payoff structure is different. So let's assume firm A chooses high, firm B's best response is low. Let's assume that firm A chooses low, B's best response is going to be low because they'd prefer to get 1 to 0. And we do the same thing for firm B. Assuming B chooses high, firm A would prefer 6 to 5, so they'll choose low. And then let's assume that firm B chooses low, then firm A will choose to get 1 over 0. And so you can see we end up here instead of the asymmetrical outcome where one chooses high and one chooses low. We end up with a symmetric outcome where they both choose low. And that's in part because their payoffs are symmetric, right? And we can see that even though this is the outcome of the game, both firms would be better off if they colluded and both charged high prices. But they both have the incentive to defect. They both have the incentive to undercut one another.
Okay, so like whichever cell ends up with both of the choices that each firm would make, that's the equilibrium?
Yep. And they're-
Okay, much, yeah, that makes sense.
Yeah. So yeah, you can't just look at the payoffs and know. You got to go through best response analysis each time.
Right. Okay, thank you.
Did you say you had a second question?
Yeah, and maybe we've talked about this before, but how would you recognize if there's no equilibrium?
So if there's no equilibrium, you'll have a bunch of payoffs circled, but you won't have 2 payoffs circled in the same cell.
Okay.
And that would be a no equilibrium game.
Okay, thank you.
Yeah, and solving those things gets far more complex, and that's beyond the scope of this course. And sometimes they're just not solvable. All right. Okay. Any other questions on this? Something else to point out in the lecture and in the book, in the chapter, we also talked about so-called extensive form games or sequential move games, where, say you got a game tree like this, and there's kind of firm A is making a choice, and then firm B is making a choice. And you use a slightly different process here called backwards induction. None of these are going to be on the exam. I wanted to kind of keep things simple, so you won't have any of these game trees on the exam. Just a heads up. Okay. Just a couple more left and we'll be done.
Sorry, I
Oh,
will
yeah.
interrupt you a little bit. So I just noticed that when you go to the form A, I noticed that you kind of look on the right side of number, and then when you try to go form B, you kind of look at the left side number. Is that how you did, or you just look at the equilibrium first?
Yeah. So the convention here is that you can think of these as ordered pairs, right? And so the first number is the payoff that firm A gets, and the second number is the payoff that firm B gets.
Okay.
And the convention in game theory is first number is the rows player, in this case A, and second number is the columns player, which is firm B.
Okay. So just to clarify, so form A is the left side number, and then form B is look at the right side number. Is that what you said?
Yep.
Okay, perfect. Oh, but also you kind of care about equilibrium for if there's both numbers are same. Is that what you said? Okay.
So the thing is in equilibrium, the 2 payoffs may not be the same. You to find equilibrium, you really do have to do the full best response analysis each and every time, because you can have asymmetrical payoffs in equilibrium, because 2 firms might be different, right? So I think there's an example of that in lecture, where I do a game where you've got Intel and AMD, and they can choose to invest in R&D or not. And then in the equilibrium of that game, the two firms get very different payoffs. So yeah, the 2 payoffs may not match each time.
Okay, good to know.
Okay, So the next one is a perfectly competitive market question. So consider the table below representing the cost structure of a perfectly competitive producer. So we've got quantity, we've got their total cost for each quantity, level of output, and we've got the marginal cost for each unit produced. You would not have the highlighted values on the exam. So the first part is complete the marginal cost column. And so just like all the other marginal values, we subtract subsequent values of the level. So here, for instance, to find the marginal cost that goes in this cell, we take 120 minus 100, which leaves us with 20. And we just do this the rest of the way down. So 150 minus 120. And then 190 minus 150. And finally 240 minus 190. And that leaves us with 50. So that's how we figure marginal costs, right? So this is the marginal cost of each unit of production. So if we, just for example, if I want to ask you what the marginal cost of the fourth unit of production is, fourth unit of output, then that would be 40, right? So we'd follow that over to 40. So suppose that in this perfectly competitive market, the price is $40. How much should this producer supply? And so you need to know a few things conceptually to figure this out. So one thing is that remember that for a perfectly competitive producer, they face a perfectly elastic demand curve. So we can think about that as there being a market supply and demand diagram and an individual seller diagram in a perfectly competitive market. And so in the market, things look pretty normal, right? So we've got, let's be good and label our axes. So we've got a downward sloping demand curve, upward sloping supply curve, and this tells us the market outcome. But that market outcome reflects its, the overall market price, which we can then project over onto our individual seller. So the individual seller doesn't face that downward sloping demand curve. They face a horizontal demand curve, a perfectly elastic demand curve based on the market outcome. And then they still have their own supply curve or marginal cost curve that slopes upward. So think of this as marginal cost. We can think about this as marginal revenue, but we can also think about it as just being the price curve because price is fixed. So let's very briefly talk about why this is the case. So this is the case in perfectly competitive markets because each producer is really, really tiny compared to the overall market. So for instance, let's think about, wheat farming in the US in the 20s. We don't have large agribusiness by that point. We have a bunch of small farmers spread throughout the country. And if one farmer decides to shut down production, they're so small relative to the overall market for wheat that that's not going to change the market price for wheat. And so insofar as that single farmer is concerned, the price is fixed. The price is the price is the price. And so that's why their demand curve is just this flat line at the market price. So moving back to our table here, suppose that the market price is 40. How much should this producer supply? Well, we need to know, okay, we're in a perfectly competitive market, which means that price is equal to marginal revenue. And we need to know that the perfectly competitive producer, just like any producer, maximizes profit where marginal revenue is equal to marginal cost. So we can then say, well, they maximize profit when price is equal to marginal cost. And this is only true for the perfect competitor, this statement here. So we can say, all right, so price is 40. So we need to equate that to marginal cost 40. And we can see that that corresponds to a level of output of 4. So the perfectly competitive producer should produce Q equal to 4, should produce 4 units of output. Any questions on that one? Alrighty, so got 2 more. Oop. Just a second. So the next one is talking about measuring market concentration. So what we have is we've got firms A through H, and each of those firms has a certain market share, a certain proportion of the market. We typically think about this as in terms of share of revenue or share of like units of output. So for instance, if this were soft drink producers, this would be, you know, liters of soda or whatever. And what I asked you to do in this problem is to calculate 2 different measures of industry concentration. And we'll start with the easier one, which is the 4-firm concentration ratio. So the 4-firm concentration ratio is just the share of the market that is held by the 4 largest firms. So first thing we need to do is we need to look through and we need to identify the 4 largest firms. And I've made it kind of easy for you here because they're listed in order of decreasing market share. So to figure out the 4-firm concentration ratio, we just have to sum the market shares of the 4 largest firms. So A, B, C, and D. So that's just 0.35 plus 0.25 plus 0.15 plus 0.10. And summing all that up, we get 0.85, which tells us that 85% of the market share is held by the 4 largest firms, which is quite concentrated. A little more complicated is the Herfindahl index, which is often abbreviated HHI because its full name is the, I think, Kreisch-Herfindahl index. So to get that, that's the sum of squared shares for all firms in the market. So to figure that out, we just do 0.35 squared plus 0.25 squared. Make sure you get that point in there. And so on. 0.15 squared plus 0.10 squared. But now for Herfindahl index, we don't just do the 4 largest firms, we do all the firms. So let me scroll over a bit. 0.05 squared plus 0.04 squared plus 0.01 squared. And so we have to go through and we have to square each of those terms and then add them up. And what we end up with in this case is 0.2242, which rounding the 2 decimal places gives us a Herfindahl index of 0.22. And so if this, so let's imagine kind of the extreme case here where a single firm held the entire market share. If a single firm held the entire market share, then they would have a market share of 1, right? And so 1 squared is just 1. And so the maximum value of HHI is equal to, 1.00. And anything less than that 1.00 is going to be less concentrated than that perfectly concentrated example. Any questions on that one?
Would you not add the 0.05 twice? the squared of those because there's two of them.
Oh, crap. I'm sorry. I just kind of skimmed over that and it didn't get that in there.
Oh, I was just making sure I didn't miss anything.
No. You're right. Thanks for catching that. Never do math in public, really. It's a poor life decision. But anyway, so yeah, you would have the second 0.05 in there. All right. So we just have one more left. Ugh. So the last one connects with the welfare analysis stuff from earlier in the course. So as previously discussed, we're going to have a different market outcome under monopoly. So I'll circle the monopoly outcome of this market in red. So that would be the higher price of 30 at the lower quantity of 100. And that, same exact process to find out that point, which is, find where marginal revenue is equal to marginal cost and then project upwards to the demand curve. And then the perfectly competitive outcome would have been where supply is equal to demand or where demand is equal to marginal cost. Marginal cost, same thing as supply, which is a quantity of 150 at a price of 20. And so all that I'm asking you to do here is, hey, here's this graph with a monopoly market. Determine the size of the dead weight loss due to monopoly. And to do that, we're just finding the area of the triangle C, right? Because dead weight loss. So to do that, we just use the triangle formula, the 1/2 base times height. So figuring that out here, we have 1/2 times the base of the triangle, which let's call this side, which is 30 minus 10, times the height of the triangle, which is 150 minus 100. And just simplifying things, 30 minus 10 is 20, 150 minus 100 is 50. And still bring the 1/2 down. So 20 times 50 is going to be 1,000, right? Yeah, 1,000. And then multiply by half, same thing as dividing by 2. We're left with 500. So the dead weight loss due to monopoly is equal to 500. And we could just as easily calculate, the difference between consumer and producer surplus in perfect competition versus monopoly, but keeping it simple, just dead weight loss. All right. Any questions about that one in particular?
Right now, maybe I'm missing it. What's the difference between calculating just regular dead weight loss and then dead weight loss due to monopoly?
So there in the calculation of it, there's nothing different. All that's different is kind of our story that we're telling as to why there is a dead weight loss. So for instance, if the same exact dead weight loss would be generated in this example if we had a price floor at 30. It just so happens that the thing that's keeping price above its competitive level, in this example, is not a government regulation saying that you must charge at least this price, but instead a market structure where a single producer has market power. But yeah, so it's just the story. The calculation of it is exactly the same.
Okay, thank you.
Yeah, no problem. All right, any other questions on this one in particular? All right, so that's all I had prepared. I am here and willing to talk about any of the conceptual stuff. There's that kind of big list of terms and concepts at the beginning of the study guide. If you've got any questions about those, we can talk about that. Or if you've come up with more questions about the format of the exam, I'm happy to answer those as well. All right, so are we all feeling good?
Sorry. So I think on number 5, do we have to like calculate it specifically to answer this, or do we just like write it down based on the question?
You can write it down just based on the question, especially since, I mean, the exam's gonna be online format as always, so I won't be able to see your work anyway. Yeah, I will say in as somebody who's taught a lot of more mathematical classes, in practice, it's always good to show your work, because when you show your work on other exams, not applicable here, but on other exams, that's where instructors try to find ways to give you partial points if you didn't get the actual answer correct. But yeah, in this, work doesn't matter because I can't see it.
Oh, but it's still like mathematic question, right? Number 5.
Yeah, like you still have to, I mean, all that's really there is kind of recognizing, that the relationship between revenue and variable costs. So, right, like if revenue is greater than variable costs, even if you're making a loss, you'll continue to operate in the short run. Just, remembering those decision rules.
Okay. Thank you.